is our second machine learning app. With this app, we're going to do a variety of machine learning techniques, and we're going to apply these techniques to a data set based on cars. So to start, we're going to import the different modules that we need. We'll be importing pandas so that we can work with our data frames. From sklearn, we'll import several different machine learning modules in order to do our analysis. And then from matplotlib, we'll import pyplot so we can visualize our results. So to start, we're going to use our cars.json file, and we're going to convert that to a pandas data frame using the read.json function. If you look here, you can see a preview of the data, and then the statistical summary will give you an idea for the sort of values throughout the data set. Now for our purposes, we're going to focus specifically on 4 different columns. We'll be using displacement, horsepower, and weight in pounds as features or explanatory variables to predict the miles per gallon. So to start, we're going to need to validate our data. If you take a look here, you can see that we have several different rows with null data. There are 6 horsepower records that are null and 8 miles per gallon records that are null. So in order to do our analysis accurately, we're going to have to remove these values. So to do that, we're going to start by converting all of these columns to the numeric data type. And we're going to specify any value that can't be parsed correctly is going to be set to not a number. From there, we're going to use the drop_na function to get rid of these values, and then we'll reset the index. So at this point, it should be a valid data set. And if you look, we have exactly 392 valid records after the validation. Now we're going to be using a variety of different regression models, so we are going to build a general build model function that's going to accept several different parameters in order to do our analysis. We'll start by passing the regression function model that we choose for that set. We're going to pass the name of the y column, which we're going to try to predict, the name of the x columns, which we're going to use to make the prediction. We're going to pass the data set itself. Then we're going to specify the test split, the pre-process functionality, and whether or not to show the plot. So we'll start by taking all of the names of our x columns from our data set and assigning those values to the variable x. Then we'll take all of the values from the name of the y column that we specify and set that to variable y. So we do have the option of passing any pre-processing functions. If this value is blank and it's not passed, then we are going to ignore this, but if we do pass a pre-process function, then we're going to apply that to all of our x values. From there, we're going to split our data. By default, we're going to do a 20% split, which means 80% of the data will go towards training, and then the remaining 20% will be used for testing. From here, we're going to take whatever regression model is passed, and we're going to create a model based on the training data. Once we have that model built, we will predict the y values using the x test values, and then we will print both the training score and the test score. If the show plot y parameter is set to true, we will also show a plot to see the actual versus the predicted values to see how well it can line up visually. And then we will return both the training score and the test score so we can use this for comparison later. Now because we're going to be doing this for several different models, we'll create a result dictionary that will hold all of this different data so we can compare it easily at the end. So we're going to start by defining a pre-processing method. This is going to be how we regularize our data. We're going to use the standard scalar from sklearn, and we're going to apply that to all of our x data. And again, this is a method that we have the option of passing, but it will not be automatically applied to every data set. So the first machine learning module that we're going to look at is the k-nearest neighbors. For this, we're going to use the k-neighbors regressor from sklearn, and we're going to specify that the number of neighbors is 10. So once we pass this model to our general build modeled function, we're going to specify that the variable we're looking to predict is miles per gallon, and the variables that we're going to use as features are displacement, horsepower, and weight in pounds. We're going to apply this to our automobile data frame that we defined earlier, and we're going to specify it to show the plot. So as you can see, when we run this model, we get a training score of 74% and a testing score of 70%. So it's slightly more accurate in training than it was in testing. But still, if you look at the visualization, the predicted and actual lines do reflect each other pretty accurately. So next we're going to look at stochastic gradient descent. For this, we're going to use the SGD regressor from sklearn. We'll specify that the max number of iterations we want is 10,000, and the stopping point is going to be 0.001. So once we apply this model to our build model function, again specifying that we're looking at the miles per gallon and using displacement, horsepower, and weight in pounds as explanatory variables to predict this, we are also going to apply the preprocess function that we defined earlier to standardize and scale the data. So once this is done, you can see that the training score was 69% accurate and our testing score was 73% accurate. So the next model we're going to look at is the decision tree. For this, we'll use the decision tree regressor from sklearn, and we're going to specify that we want a max depth of 2. So once we apply this model to our general build model function, again specifying we're looking for miles per gallon, you can see that the training score was 73% and the testing score was 74%. So it was slightly more accurate in training than it was in actual testing. So the final model that we're going to look at is the random forest. Again, just like with the decision tree model, we're going to specify a max depth of 2, and we're going to use the random forest regressor from sklearn to do the analysis. So once we apply this model to our general build model function, you can see that the training score was 78% and the testing score was 68% accurate. Now in order to compare these, we're going to create a really general compare results function to print out the regression type that we used, the training score and the test score for each. And when we apply that to our result set, you can see the comparison down here. It looks like the most accurate was our standard gradient descent model with a 73% accurate in testing. And the least accurate was the decision tree model with only a 64% test score. And that concludes our second machine learning app. Thank you.